Alright, so I spent the last month making a video meticulously measuring signal-to-noise ratio, only for a series of videos to come out by other astrophotographers saying that using SNR calculators are not useful. We're recording? Sorry about that. Welcome to Deep Sky Detail. This video is going to be a bit different than my previous videos in that I kind of just want to get it out there. I don't want to work for a couple of weeks or a month on it to make it polished because I want to work on other projects. But in the past couple of days, there have been a few videos that have come out and have talked about SNR calculator apps. And part of the conclusions that some of those videos made, and I'll link them in the description, was that maybe SNR calculator apps aren't that useful. I'm not here to say that those videos are wrong. In fact, I agree with a lot of what they've said, and that SNR calculator apps a lot of times aren't that useful, especially the default one in PixInsight. This video isn't going to be like any response to what they've said specifically, but kind of what those videos said generally. I think if you want to go see those videos, you can just go check them out. But I'm going to make this video sort of in defense of SNR calculators, especially if it's a good SNR calculator, and I include Craig Stark's calculator in the category of good SNR calculators. It's the one I base my SNR web application on. In a bit, I'll actually demonstrate that the SNR calculator app can be just as good as real-world SNR calculation. So, what has this channel been about? If you've watched my videos over the course of the past year and a half, you know that a good chunk of my videos are about demystifying signal-to-noise ratio and making it understandable. So, for example, if you see my SNR calculator app and it says an SNR of 30 is good, what does that mean? I actually have a video about it. I realized that people don't know what an SNR of 30 or 60 or 90 should look like. So I made a video about it. And I do think a lot of what was said in those other videos about just going out there and taking more photos, trying to get into darker skies to get better data, that's all true. I agree with that. A lot of the SNR calculators out there are just not very good. I've seen multiple videos over the past few years criticizing, for example, the default PixInsight SNR calculator. It's just not very consistent. Each time you plug in the numbers for different subs within your imaging session, you might get radically different numbers. Sometimes the stacked image has less SNR than a single subframe, which doesn't make any sense at all. So again, I get what they're saying. I get it. I understand. But I do want to say that I think that the SNR calculator app that I've created that is based on Craig Stark's work is actually very good if you use it correctly. So before I get into that, let me talk a little bit about my personal story. So I started astrophotography around 2016, 2017, so almost 8 years ago. I lived in a Bortle 9 zone. I had an unmodified DSLR and I was in graduate school. I didn't have a lot of money. So not much different than today. I saved some money and I bought myself a used mount and an ED doublet. And I just used my DSLR and I was happy. But let me show you an image for a second. So I've got this image open in Serial, and this is the stacked image. And let me show you what an unmodified DSLR does in a Bortle 9. Yep, this is it. Can you tell what it is? If I just glanced at it and looked away, I would have no idea what it is. I really have to zoom in on there to actually see something. I know most of you already know what this is. But even then, you can barely make out the Horsehead in the Horsehead Nebula. There's a lot of walking noise. There's a whole bunch of other stuff that's wrong with this image that is just me being a noob at astrophotography. Really, if I had known about Craig Stark's Excel sheet and I had just plugged in some of these numbers, I would have realized that this image is not going to turn out well before I actually spent hours and hours trying to image it. It was actually a lot of work. I had to change the batteries in the camera in the middle of the night. With the calculator, I would have said, okay, I need a brighter target in my Bortle 9 zone, and I would have skipped this and waited until I went camping or something. This is obvious to me now, but it wasn't obvious to me as a beginner. What I thought was obvious was just get more integration time and you'll be fine, which in my case was not correct. I think one of the main criticisms is that an SNR app is all theoretical. There is a difference between theory and practice. If your experience is like the PixInsight SNR calculator app that is all over the place, you're going to have a bad taste in your mouth about what is theory and what is practice. In reality, your theory should represent what happens in practice. I'm pretty sure that as an astrophotographer, if you do astrophotography, you stack images. Stacking images is all about the theory of signal to noise ratio. If I have an SNR calculator app, I should be able to get reliable SNR measurements from that and be able to plan my image. If it's not the case, then the theory is no good. I think when Craig Stark created the Excel spreadsheet, he tried to make sure that the theory really related to the practice. Honestly, the SNR calculator app is not putting in theoretical numbers. You are getting your sky globe plus the deep sky object signal. You are getting the sky glow signal, and you're getting all these other noise values taken from real measurements like your bias frame. I feel that you have to do that in order to get a good SNR measurement. These other algorithms like in PixInsight that try to do this automatically for the whole image are no good because they make the wrong assumptions. The theory is wrong. So let me show you an image. Hi, it's me from the future. One quick point I want to make, the data that I'm about to show you is very clean, so it's quite easy to get a good real-world SNR measurement. One big problem that is a very valid criticism of SNR measurements is that they can vary wildly if the sky conditions are different. I think this really points to the fact that you need to remove data from your stack that is of poor quality. So if you've got high-level clouds coming in and messing up your subframe, then you really need to remove those from your stack because they're not contributing positively to SNR. But again, this is a very valid criticism of SNR calculators because they don't really take into account that noise. So when you do use an SNR calculator, if you do choose to use one, which of course you don't have to, is to make sure you get a good subframe, like an average subframe, and that you are removing data that is of poor quality and don't stack those into your final image. All right, see ya. So I've got this image open up in Zero. This is a subframe from Messier 106. I've gone ahead and I've gotten to sky globe plus background numbers, and I've got also the sky globe background numbers. This image was taken with my old CCD camera and my 80 ED doublet. So what I'm going to do is I'm going to go ahead and put in those numbers for the SNR calculator app. Give me 1 second. Okay, so I've put in all the numbers into the SNR calculator app. 20 subframes, the SNR calculator app says that I should get about 18 SNR. So again, let me show you again what part of the galaxy we're looking at. Okay, so now I've got RStudio open that runs R. Let me go ahead and pull this up for you. Okay, so this is the same area, the same sample that was highlighted in Zero. And this is the function that I've created that will calculate the real SNR based on real world data. Now, the only way I know how to calculate SNR in real life with real data without a calculator is to find the brightness of a subframe, stack an image on it, find the new brightness, and measure the noise in an unbiased way while taking into account the sky glow background. Keep iterating for as many subframes as you have, and this function does that. I have a couple of videos that go into more detail, but this gives you an accurate real-world signal-to-noise measurement. Okay, so I actually have 20 subframes. Okay, there we go. We have the results, and you can see here that it starts around 4 or 5 and goes all the way up to about 18. We can actually get those values here, put it into the console and run it. And you can see that the last value, the last signal to noise ratio estimate is 17.6. Again, let's go back to the SNR calculator app. This was just estimating the SNR based on one subframe. So here's the SNR calculator app. Here's the actual real world measurement. We start about 4. When we get to 20, we're at about 18, 17.99, which is very close to the 17.6 that we actually measured in the real world experiment. Are there caveats with this SNR calculator? Sure. Within your stack, you have to choose an average subframe to take the samples from. For broadband, things like the moon can really affect the estimates, but if you're careful, it will give you good estimates. About some misconceptions about the SNR calculator app, that it measures SNR in decibels. I kept everything in raw SNR, and that's a deliberate choice. Decibels are useful for human perception, but decibels are not a unit. Just like signal to noise ratio is, there are no units with that. You can think of decibels as a way of making very large numbers smaller. For sound, an increase in 3 decibels equals a doubling in sound intensity. But like the sound of a whisper may be around 30 decibels, whereas normal conversation could be around 60 decibels. Between that 30 and 60, you have several times where the sound intensity has doubled, but you don't perceive the absolute difference in loudness. Everything is sort of relative. And here's the thing. With decibels, you need a good reference point. For sound, that might be the sound pressure that represents the softest sound a human can hear. I don't know what the reference point is yet for astrophotography images. There may be some standard out there. I haven't researched it, But without a reference point, decibels are meaningless. I do think that the way to do it is to get the SNR of parts of your image. And then there's one last thing that I want to say, and that's a quote. I think I read this on Cloudy Nights, and I'm sorry if I'm butchering it. I couldn't find it. He said, astrophotographers don't spend time and money to just minimize imperfections. They spend time and money to completely eliminate imperfections. If you think about it, you might have an apochromatic refractor. You want the stars on those edges to be pinpoint. So you buy a field flattener. You want the best mount possible. You're trying to get rid of as many imperfections as possible. And that's where an SNR app really shines. What you can do with Craig Starks is compare the SNR of different configurations. You can say to yourself, how much does this filter affect my SNR? How much less imaging time will I need with this filter compared to without it? You're spending so much time and money trying to make things perfect. An SNR calculator can really help you figure out whether you're achieving that goal, and it can help you figure it out quite quickly. Do you want to know whether your refractor is getting better SNR than your reflector? Measure it. Put those things on your mount on the same night, take some images of the same object, put them in the app. The last two videos I made, I didn't know what was going on with the ASI 2600mm camera. I had a few people contact me and say, look, I'm not getting as good SNR with this camera as I thought. What's going on? And that led me to measuring the SNR of the camera and my old camera, and it led me to doing some experiments. It led me to figuring out that the camera's fine. It's just the pixels. The pixels are smaller than you might want, and it's getting less SNR than you think. What you can do is bin. That's one solution. If you don't want to lose the resolution, don't bin, it's fine. But if your images aren't as bright, and you need more integration time than you think you should, well, now we've got an answer for why that is. So are SNR apps worth it? I don't know. For me, Craig Stark's app is worth it. It works. You do have to be careful. You have to get good measurements when you put it into the app. But if you do, you'll get good estimates. If you live in a border 1 zone and you have decent equipment, you may not need it. You can probably go out and image anything you really want and get a nice image. And it's fine, it's okay. But when I was starting out, if I had known about Craig Stark's astrophotography Excel spreadsheet, I would have used it and I would have been able to have a better idea what targets are worth shooting, given my skies and my equipment. Anyway, thanks for watching my video. If you want to use my SNR calculator app, feel free. It's free. I'll put the video here, and if you don't, it's fine. You do you. Thanks for watching.